Hello, my code goblins. We're here with another edition of Conquering the JavaScript Interview with your host, Luke. Me. That's me. It's me. Anyway, yeah, we're here picking up with another array algorithm for this playlist series free YouTube course, where we are going to be coding and attempting to solve what I'm going to call it array sum finder. Write a function called wow sum finder, which I mistyped. There we go. Professional, hashtag professionalism. Get in the comments. Let me know how professional I am. That takes two arguments, an array of numbers, r, and a number sum. This function should return a Boolean value of true or false if the sum can be found between any two array elements. So as my two examples right here, it's going to be short console log, so I don't need a huge node window there in my terminal. An array of the values 6, 4, 3, 2, 1, and 7. If we plug in a sum of 9, we know that 7 plus 2 in this array can generate 9, which means we will return true. And if we have a sum of 2, there's no two numbers in here, for example, a 1 and a 1, that would put out the value sum of 2. No two numbers in here can sum to get that value, thus we can get false. So I'm going to go over 3 different solutions in this video, try to explain them to you how they work, and tell you some of the pros and cons to using one versus another. Again, that's what a lot of these boil down to, depending on how complex we need to make them. It really depends on what our interviewer may ask us and at what level of interview we're going into. Because if you're, again, I'm going to mark this as possibly intermediate, but nevertheless, like coming in here and trying to overcomplicate it for beginners is not my goal, because again, the better you get, the more you'll realize there's certain edge case scenarios where you can return early and do other checks like that. Like for example, we can say, oh, if the array length is greater than 1, then there's no point in running any of this code logic here and just return false, for example. Yeah, we could do that, but again, keep that kind of stuff in your back pocket. Get in the comments below and always add those little edge cases for future viewers of this playlist series to make sure we kind of collaborate together and build an awesome comment section underneath these algorithms that could have, additional tidbits added to them, efficiency and performance, comments and questions being answered. So yeah, without too much further ado, let's just dive on into our first solution here. So, we have an array, and it's a pretty good idea to consider that a for loop or some kind of iteration is not far behind for this solution. So this is one of those, I don't know why when I was in y'all's shoes trying to, I remember getting not asked this in an interview, but I think it was like HackerRank or LeetCode or some kind of GitHub repo of like practice algorithms I found. For some reason, this one took me a while to truly understand, so hopefully I can do a decent enough job to get your minds to wrap around it here. So the first solution we're going to go over will be using, surprise, a for loop, and actually 2 of them, right? Two for loops, one nested within the other, which of course is a big O of n squared. So, not the most performative solution, but I think it's the easiest one to understand as a beginner, which is where we're going to start. So what you need to think of it as is almost like we are grocery shopping, right? Imagine you got a shopping list, your array, and it has a list of items that you want to buy at the store. You've also got a budget, the sum argument of our function here, right? So this is our shopping list, this is our budget. That's what we're going to think of this as. We want to know if it's possible to buy any 2 items on our list that add up directly to our budget. And so, 2 items at the grocery store, that doesn't sound like much as a shopping list. Let's just say it's like a list of possible candies that we want to buy, right? So it's like 10 different candy bars we want to buy, and we got to figure out which 2 we can buy together that will equal our budget. So what we're going to think of it as here is we're going to start at the beginning of the list and compare the first item with every other item on the list. If I find 2 items that add up to my budget, I can stop looking then and there because I found a matching pair of items that I can buy. And that's when our function will return a true value, and right away we can stop iterating at that point as well. So we can return a true value from the function when we find any 2 items on our list that equal our budget, right? So if I don't find a matching pair, I move to the next item, and then I compare it to everything in the list. If that's a miss, move to the next item, and then compare it to everything in the list. And we keep doing that until we've checked every possible pair of items on our list. And if we've checked every single pair of items on our list, we know it's not possible to buy any 2 items, or candy bars, that equal our budget, in which case, if we get that far, we return false from our function. That's essentially what we're going to be doing here with our array of numbers and our sum argument. It's going to check every possible set of elements in the array to see if they equal the sum argument. If it finds a matching pair, returns true. Otherwise, the default is to return false because nothing was found to do so. So that's what I want y'all to take into consideration as we code our way through this one. So without too much further delay, let's get going here. Right, so like I said, we need to write a for loop that will go through the array. Let I equal 0. As long as it's less than the array length. Cool beans. Then this will loop through each number in the array. What we need to do is have another loop compare that number to every other thing in the array to see if they can sum together to get to our candy bar budget. So this inner for loop, again, we need to use a different iterating variable name. We'll go with J, is going to start wherever I is +1. That's how this loop is going to go. Just, again, if we're on the first item in the array, there's no point in comparing the first item to itself, so we go to the next thing and then run through that list to compare it. Hence why it's always going to start wherever I is +1 index position for our inner loop. That is going to continue so long as it's less than our array length. And we're going to iterate j by 1, so this is going through each item in the list, 1 by 1, and this is running the comparison of every other item on our candy bar shopping list to whatever we're checking against, right? So again, this one goes through each item in the list. This one takes and compares each item in the list to every other item in the list, okay? Then we are going, like I said before, if it gets through all these loops, we know that there are no candy bars in our shopping list that could be added together. No 2 candy bars can be added together to get to our budget. So we're going to return false. Now we need to simply have a condition to say if something ends up adding to our budget, we're going to return true as our Boolean value here, right? That's going to return true if we get a matching pair. So all we have to do is check the current item represented by that right there to see if it is added to our comparative item. If those 2 candy bars added together equal our budget, we have to return true. And that is the nested for loop solution. Again, the one that I eventually, when I was a newbie, eventually began to understand and come to terms with. Let me scrunch some things down here for a visual aid. There we go. All right. There is our double for loop solution that took me some time to understand, but I get it now. So hopefully the shopping list analogy of like kind of in your mind's eye going, yeah, I would just look at the item, compare it to everything else. No. Move to the next one, compare it to everything else. No. Move it, compare. Oh, I found 2 that sum together like I want. And yeah, that's how this little for loop, double nested for loop solution works. Let's give it a whirl, see if she works. Console log, because I don't have any logs inside of there this time. We should hopefully see a true on this one, and we should see a false on the second line. So let's run these 2 as a quick test, see what happens. True for the first one, because we do get a sum of 9 between at least 2 elements, and a 2 gets us a false here, right? So a 5 as a test should also give us a true, and then what number can we not get? Well, we can't get a 20 anywhere inside of there, right? So we should get another true-false readout. Yeah, so we got another true-false readout, which means we are good to go, folks. This is working as we expected. All right, so what else? That's it for the double for loop solution. So take your screenshots or do whatever you need to do. I've been debated on putting some of these solutions in CodePens and linking it, or even starting a big repository with these written, like with this thing written out with tests or something like that. If there is interest in that, let me know in the comments down below. Or I might put that part behind a paywall. Gotta pay the bills, right? Anyway, let's move on from this one, because like I said, it's all right. I think it's the most legible of a lot of the solutions. It's the first one that I began to understand how this works. And when you're comparing items, elements in an array to themselves. That makes the most sense to me. And again, being that it's a nested for loop, it's a big O of n squared, which is not super performative the larger your data set gets. So yeah, moving on from this one, let us, I'll comment this one down below. We'll say SumFinder nested, and that way I can move it down yonder, right? So we can always scroll to it if I need to. This one is going to be a different solution. So let's nuke our code and start from scratch. And let's also take some things into consideration for the next one. Okay. So this next one, I will be using an object or a hash table. So if you need to remind yourself what one of those is, I mean, it's an object, right? Key value pair storage of some kind. I'm not going to be using like a weird data structure, but if you are curious about what a hash table or a hash map is, check the description down below, as I'll have a link to that data structure video I made not but a few weeks ago. Right. So how am I going to drop the comparative part of the inner for loop and replace it with some kind of way of keeping track of what pairs I have seen? So we're going to think of this one as, I don't know, like let's throw out a restaurant or something like that. We're at a restaurant. That's the array with a group of friends, and you want to split the bill evenly, which is our sum argument. You want to know if any of the two items on the menu, the numbers in the array, add up to the total bill so you can split them between two people. To do this, we're going to start at the beginning of the menu and look at the first item, the first number in the array, and we're going to check to see if there's another item on the menu that, when added to the first item, equals the total bill. So this is kind of like the same thing with our shopping, right? Just like before, if we found a pair of items that equal the sum, we can stop there because we now know we can split the bill between two people the way we want, aka our sum. If we don't find a matching pair, we simply move on to the next item in the menu and check there's an item menu that, when added to the second item, equals the total bill. So we keep doing that until we check every item on the menu. And you're wondering, Luke, how is that different than our candy bar shopping analogy here? Again, I think the restaurant is superfluous because it's the same idea. But what we're doing differently this time is we need to keep track of the items we've seen so far. So in that first double for loop solution, we just compared everything to everything all the way through. But we technically don't need to do that because if we've seen a pair already, we can create a list to tell us what we've seen, right? So that's what that object is going to be. We're going to call it the seen object. And we're going to add each item we see to that list. So when we look at the next item on the menu, we can check to see if the difference between the total bill and the item we're looking for is in the list of items we've seen. If it is, I can add the current item to that item to get the bill. So I return true. If I don't find a matching pair, you add the current item to your list of seen items so you can check for it later, right? That's essentially what the SumFinder function is going to do with our arrays of number. In the sum argument, it's going to loop through each number in the array and checks the difference between the sum argument and the current number we have seen before. If it has, we know that adding that number to the current number will get us the sum we're looking for. And if we don't find a matching pair, we're going to return false. So this one is going to have a big O of n because it's going to only utilize one for loop, a little bit of math, and an object. So while it may be faster in terms of complexity, big O of n is way faster than n squared, because we loop through the array only once, it could have some space or memory issues because we're going to have to create an object, and the bigger our data set gets, the bigger the object is going to get. So let's start coding this one out after we kind of think about it in a different way compared to our candy bar solution of just checking every single possible combination all the way through. All we need to do now is mark down ones we have seen, and with a little bit of math, we can get it solved in no time. So like I said, we're going to start by saying, hey, let's have an object where we're going to keep track of what numbers we've seen so we don't have to compare everything all over again with a for loop. Like before, I need at least one for loop to go through my array of numbers. So we'll do one of these. This is going to be a bread and butter staple. We're going to see a lot in our code here. If it gets all the way through the loop and the loop hasn't told us that we've seen a pair of numbers that is addable to our sum, we're going to assume that it's going to return a false value because, well, ain't nothing in there that matched up. Now there's there. All right. So for keeping track of things, we'll say that right there is our current number we are looking at. Right? What we want to know is if the difference of the sum minus the num gets us what we need, right, we can return true because a pair of numbers got us what we're looking for. Otherwise, we add the number into our scene object, right, until we get there. So let's check it out. We can say that every single time we don't find a match, we're going to say to our scene object, remember this is square bracket, not dot notation, we're going to take that number and make it a property in the object and give it a truthy value. So that's what's going to happen in the event that we find a number that doesn't get us the sum we're looking for. We're going to add it to our scene object and compare to it on the next iteration. Okay? So here is where we have to write some logic to say, hey, we're going to return true if we've seen this difference before. Okay? And this logic is as simple as saying, if we have seen this difference before, we know that there are two items on our restaurant menu, or our bill, that can be added together for us to split evenly, aka our sum. So the analogy here was kind of a rough go of it, but yeah, hopefully once I console like a couple of things, you'll see how this ends up working out. So again, the point here is that we keep track of numbers we've seen inside of here, okay? And as we go through, if their difference is a number in our scene array between the number we're looking for minus our current number, if that difference is a value, exists in scene, we got it. This number with what we've seen in the past added together gets us our sum, which is why we get to return true. If that doesn't happen to be the case, we say, hey, we've seen this number, we're going to add it to the object and move on to the next number in the array. Right? So that way, when we get down here to I think the only possible solution here to get, the first solution to get 9 would be 6 and 3. Right? So we say, hey, we've gone through 6 sum, which is 9, minus 6 gets us 3, which is a difference. We don't have it in the object currently. We add 3 to the object, so the object ends up looking like this. Right? Because JavaScript will string, I think it'll take the number property and make it a string. In JavaScript objects, they have to be string properties. It'll add that to our object and then continue down the line. So, okay, that's what that diff was there. It goes on to the 4. So num becomes 4. Sum, which is 9, minus 4 would be 5. It does not exist, so it's going to add that. Then it moves on to the 3. Ooh, let's see where this is going already. Then it moves on to the 3 as our num. The sum, 9 minus 3. Yeah, gets us 6. And that hasn't been seen, so then it continues on the line. That doesn't make sense. Am I confusing myself here, y'all? Because then it would technically add 6 as true, and I guess it goes down the way until it finds... What am I overthinking here by doing this iteratively? Hold on. Let's just console log this sucker out, because now I'm curious. I like how I've managed to confuse myself in my own explanation, despite knowing that this math should check out just fine. Because we should get true-false once again. Yeah, there's the true, because it returned true. So I did do this wrong, mentally. And then false the second one, because it never actually gets there. So yeah. What did I mess up in the first place? Because it'd be 9 minus 6 as the first one. Unless it's... I mean, I'm not sorting the array. Oh, my God. It adds the number to the array, not the difference, Luke, you dummy. So I did screw myself over by thinking about it incorrectly. My bad, you guys and gals and everything in between. I did mess up there. Luke. Yeah, so I did mess up by saying it. In my head, I was thinking it correctly, and I stated it wrong and kind of went down that path. So this is what we actually see. We get the difference, right? We don't see the difference in the array, so then we take the number, which is 6, and add it to the array of saying, hey, this is a number we've seen. Derp. Okay, so back to it again. 4 the difference, the sum of 9 minus 4 is a diff of 5. We haven't seen that. We don't add 5, we add the number, which was a 4, saying we've seen this before. Okay? Then it goes to the 3. It says then, num is 3. 9 minus 3 gets us 6. This is what the object currently looks like. Is there a 6 with a truthy value inside of the object? We've seen it, which means the 6 that we've seen before, along with this 3, added them together, means they can be our sum, aka return true early. So hopefully me walking it through and even making the mistake, because again, like, I'm not saying these are all easy to memorize or understand. I wanted to take y'all through them. You can see why we get the true and false that way, right? We basically keep track of the number we've seen. If we've seen it before, because of the difference between sum and minus num, that means our current number added to a previous number we've seen would indeed check out as true. Okay? So that is that solution. Like I said, has a complexity of just n because we only loop through it one time. However, if in a big data set, that object could be very, very big. So if you have memory space issues, then you might go back to the less performative n squared potentially. Now, I have one more advanced one that once again, I'll have to probably break down step by step for y'all to understand how it works. So pause and screenshot whatever you need to. And we're going to move on to our final solution. I can't say that out loud. We're going to move on to the third solution I have available here for our code. It's still going to have a loop. We're going to write it a little bit differently, though. And this one is going to have a goofy way of thinking about it, right? Basically, what we're going to be doing in this particular solution is we're going to be using some pointers. And the way this is going to work, the only way this is going to work, is if we sort our array, which has not been any kind of condition I've had to do here, right? I haven't had to consider, are these arrays in an ascending or descending order or something like that? I didn't care. In the first solution, I just compared the number to every other number every single time until I found some two that added together. In this one, I simply stored numbers I've seen before, and then when I found a difference that corresponds to a seen number, aha, it's true, those two can be added together. This last one is going to sort our array, and then using pointers, we can think of them as fingers going down the row until two numbers add together to get our sum, right? That's what we're going to think of it as here. Right? We're going to know that if we're like in a theater, right, with a numbered row of seats in an order that we can predict, right? That's going to be our sorted array. I can look at the list of seats with a left pointer and a right pointer, meaning like the beginning and the end of the row, and basically check the price tag of each seat and then move my pointers inwards until I find two seats that get me the sum price that I'm looking for, right? Yeah, so basically, if the total price is less than the sum argument, I move my finger to the right and check the next seat. If the total price is greater than the sum argument, my friend moves her pointer to the left and checks the price of the previous seat. We keep doing this until we find two seats that add up to the sum argument, or when our pointers cross each other, right? Yeah, this one was rather difficult for me to try and figure out how to explain, but I thought it was a cool solution, so I'm going to put it in here, right? And this one also gives us the first time we've probably seen any kind of weird complexity beyond n squared and n, right? This one has a complexity of log n, right? Which technically a logarithmic scale is better than the nested loop solution, but worse than the object solution. So again, which one should I do during the interview, write the one that you can memorize and figure out and make sense of, which I would argue is either the nested for loop solution or the seen object solution. This one I'd throw out, and if I felt very confident and I was interviewing for something beyond a beginner skill level. So this is why I'm probably marking this video as intermediate skill level, because this particular solution is definitely going to be a bit more tricky to finagle in an interview. But let's see if I can help y'all figure it out. So I'm going to take this and say that's our hash table, our object, whatever you want to call it, see it function. I'm going to copy this. Nope, not everything. Just my function here. Copy and paste it down yonder. So if I need to scroll to it so I can show y'all how it looked again comparatively, we can. We're going to merc this code inside of here and rename it down to SumFinder. So here we go. in this particular case, we need the array to be in an ascending order so I can have a pointer at the left, we're going to call the beginning, a pointer to the right, which we'll call the end of the array. And like I said, we're simply going to move our pointers and compare numbers until we get the sum we want. Otherwise, we return false, just like before. So as before, ultimately, if everything above the return false has failed, that means no two numbers in this array can be added together. So we can go ahead and just return that false right there. Like I said, I need to sort the array. So I can say, hey, reassign the array to be a sorted version of itself. We're going to say A, B. And then the comparison will be A minus B. That should get us our sorted array, which if y'all are curious, we can take a look at right here to see if she works. Yeah, so it's sorted the array of numbers for us right then and there. So that's what that little bit of code is going to do, right? We need to have it in ascending order because this is where our, right, that's going to be our left pointer, which means it starts at index 0, aka the 1. Then we need a right pointer. And the final index position of any array, newbies, is always its length minus 1. That's going to be the final index of any array that you can quickly solve with some math, aka in our case, it's the 7, which is 0, 1, 2, 3, 4, 5, aka 6 minus 1. So the fifth index position. That's where our right pointer is going to go. Like I said, we keep on checking each item with our pointers and moving them inwards. Once they cross, there's no point in continuing because our, what's it called? Because by that point, we've already compared everything from the left and right-hand sides because it's being of ascending order, which means we don't have to continue. So we're going to run what's called a while loop to say, so long as the left pointer hasn't crossed the right pointer. Once they've crisscrossed, there's no point in continuing. We can return false because no two seats in our row of seats here had a price tag that was our sum value that we're looking for. Okay, so imagine these are a row of concert seats, and the number they correspond to is their price tag. And we're trying to find, hey, any two seats in this row that can sum up to 9 is what we're doing here, okay? And like I said, we can imagine either two of my hands or a friend and another friend are starting on opposite ends and pointing to their respective seats going, I got a 7, what do you got? I got a 1, that's not 9. Okay, so you move yours in. I got a 2 and a 7. Oh, that equals 9. We got a solution here, right? We have a way of getting 9. So that's how this solution is going down the way here. And then if there was no solution, like we are going to try and find two price tags that wind up with 2, that ends up being impossible because once our fingers cross at the midpoint, we're like, there's no point in continuing because we clearly on both of our checking ends here haven't found anything that can sum up to 9. So what we need to do is look for our current sum that we're looking at in our seats here. So I can say our current sum is going to be whatever we're looking at with my left pointer added by my right pointer. In my analogy just a moment ago, we're looking at this array here in my console log above my fat head. My left pointer is looking at 1. My right pointer is looking at 7. So their current sum is 8, which is not what we are looking for, right? So how we're going to say that? If our current sum equals the sum argument, we know then hey, these two seats have the right price tag, which means we can return true. Okay? If the current sum is less than the sum I want, we need to move the pointer to the left because it's too small. So I can say, if my current sum that I'm looking at is less than the sum I'm looking for, we're going to continue on, which means we're going to increment the left pointer by 1. If the current sum is not equal to, is not less than, but the only possible solution we have left is greater than, then I'm going to move my right pointer in 1, right? So if the current sum is too large, move the right pointer in 1 time. So basically I say, hey, it's less or it's greater than, move the right pointer in, and we keep testing until we get there, right? So that's how this logic is going to play out. And if we find a matching pair, we return true early. Otherwise, we keep on incrementing left and moving the right pointer in. At any point they crisscross, the loop will stop. And that is how we're going to wind up with this particular solution, which, like I said, had a n log n logarithmic curve, which is better than our nested for loop solution, worse performatively than our object or hash table solution. But this one doesn't need a massive bit of memory that the object might get in a large scale thing. So I'm going to clear the console real quick and just rerun this after I save it. And true, false. Once again, true for 9, false for 2, and we got our solution written out here in a clever way of using a sorted array and pointers. So 3 different solutions I'd rank as not too bad, still not too bad, and then what is this craziness? That's what I thought of when I came across this particular one online and began to wrap my head around it, but it is pretty cool once you figure out how these pointers end up working. And it's something you will commonly see across some more advanced solutions as well. So I wanted to, again, load up y'all's tool belt with the tools to solve the job here. So let me scrunch this in so we can see it all together. Yeesh, right? That's what the code ends up looking like here. And it's pretty dang cool if you can wrap your mind around it, right? So like I said, it's a complexity of log n. So I can't say that there's like a best solution, because the common cop-out answer I give to all of my students is, well, it depends, right? You have specific situations and requirements of the problem that will dictate which one will be your better, right? If the array is small or performance isn't an issue or a concern, or if you're going for a beginner interview, throw out that nested loop solution, because it's the easiest to probably memorize and write. It's very straightforward, it's simple, it's easy to write the code on a whiteboard and implement it in, but its complexity is n squared, which can be a problem once the array gets very large. N being your input. I should probably make a video on what is big O notation, because my beginners aren't going to know that. Duly noted in real time at timestamp 31. Okay. That's going to be a problem if the array is very large. The larger the input gets, aka n being squared, that number is going to get really large really fast. If the array is super big and performance is a concern, then the hash table is going to be your best solution, because it has a complexity of big O of n, meaning it's linear. The bigger n gets, the longer it takes, but not in a quadratic way, not in a exponential way. So that's going to be our choice. If we can use, if memory space isn't required, then the hash table solution's the best way to go. Right now, the 2-pointer solution, the 2-pointer left and right solution, has a complexity of log n, which is better than the nested loop solution, but worse than the hash table solution. However, the hash table solution may require a ton of extra space as that scene object grows in size, because the pointer solution uses 2 pointers, numbers that go up and down, and a sorted array, and that's it, right? So those are better for their complexity, but the choice really depends on, are you looking for simple and straightforward and doable? Are you looking for the most performative, or are you looking for the most memory efficient? And based on which question you're being asked would dictate which one of these answers you would give out. So I'm going to say at the end here, thanks again for watching, you guys. I hope you found this video helpful in I think I said your at one point, but honestly, this is our journey, because I get to learn just as much from my students and the questions and the crazy comments and solutions they come up with, right? Every single time. So hopefully you found this video helpful in our journey to become better developers. If you enjoyed this video, please give it a thumbs up and consider subscribing to our channel for more videos like this. Also, I would love to hear your thoughts on the algorithm covered in this video here. If you have any suggestions for alternate or more efficient solutions, if you can beat these, please share them in the comments below. Remember, constructive and positive comments are always welcome here. Let's keep the discussion going, help each other improve our coding skills. Thanks again for tuning in, and I'll see y'all in the next video.